Okay, so the first one say an object dropped from rest from the top of a tall building falls y is equal to 16 t squared feet in the first t seconds. So, number 2, we start with y is equal to 16 t squared. Oops. And this one says find the average speed during the first 4 seconds of fall. Okay, so this is during the first 4 seconds. So this one is going to be worded a little differently than the next one. This means I want to know what's happening in that whole time frame. Okay, not at a specific time. Okay, so with this one, we're going to use f of t plus h minus f of t all over h. Okay, and it says that we started from rest, so that means that initially it's going to be 0. So another way you can think about this, okay, delta y over delta t. So we're taking this whole function, okay, and we're filling in the t plus h, or t as the case may be. Okay, in this case, since one of the times is 0, I'm just plugging in the 4. Okay, so it's going to be 16 times 4 squared minus, okay, in this case t is 0. Remember, it starts from rest and we're wanting it at that whole interval. So t is 0, which is our initial time. So that's going to be 16 times 0 squared. So that piece is going to go away. Okay, anything times 0 is 0. All divided by h is 4. And so then you'd have 16 times 16 divided by 4. So that'd end up being 16 times 4. Huh?
64.
Yeah. 64 feet per second. All right, so the next one is going to follow the same principle, but the difference here is that it says to find the speed of the object at t is equal to 4 seconds and confirm your answer algebraically. Okay, so this is at a specific instant of time. So now, we're actually at t is equal to 4.
Would this just be the same thing as before, except we don't divide by 4 at the end?
Sort of. Close. And we're still dealing with y is equal to 16t squared. Okay, a common mistake here is that people will go, oh, at t is equal to 4, it's 16 times 4 squared. But that's not true. Okay, that's not how we have to do this. So we're going to use the same formula here, delta y over delta t. In this case, 4 is going in for t.
For both of them? Because it's technically our initial as well.
What?
We put it in for both of them?
No. The other value is unknown. So 16 times 4 plus h squared minus 16 times 4 squared all over h. And now I'm going to boil this out. So 16 times 16 plus 8h plus h squared minus 256, all divided by h. So then on top, it's 256 plus 128h plus 16h squared minus 256 all over h. Okay, my 256's, one's positive, one is negative, so they're gone. Now what do you see that I can do?
Pull out of H.
Can pull out a h, so that's gonna leave me with 128 plus 16h right? Hold on. Oh, yeah, this is right. So now, because I want the instantaneous speed at that time, the limit as h approaches 0 of 128 plus 16h is equal to, any ideas? So a hint with limits is that essentially you're plugging in a number. You're plugging in whatever it's going to for that value.
Whatever it's going to.
Yeah, so in this case the limit is h approaches 0.
So we plug into.
I would essentially put a 0 there. So it would be 128 feet per second. That's the instantaneous speed, which is what it wanted at t is equal to 4 seconds. All right, next one say to use the limit as x approaches c of k is equal to k, and the limit as x approaches c of x is equal to c to find the properties, and the properties of limits to find the limit. So, it's okay, this is a quick problem, I promise. Number 6, it's probably the easiest problem in the whole section. As x approaches c of x to the 4th minus x cubed plus 1 over x squared plus 9. You're just using the properties, okay? You can't solve anything. It didn't give us a number to figure out what the limit's equal to. So it's really as easy as just plugging in. Anywhere you see an x, you write a c, and whatever exponent was with it, you keep with it. And that's literally all you have to do for those ones. Cool?